Real-world scalable entity resolution. Hi, I'm Nick Bates-House, Chief Architect at Tamr, and in this 5-part video series, we'll talk about what makes entity resolution challenging at scale and what Tamr has done to meet those challenges. In this first part, we'll give an overview of why entity resolution is so hard at scale. We'll talk about the background to the problem that we're trying to solve, the challenges that we meet along the way, and give some measures of success. First, background. What problem are we trying to solve? Let's say we have 1 billion customer records, and we're trying to find records that represent the same customer. To do this, we need to compare every one of those billion records with every other of the billion records. This is 10 quintillion comparisons. If we can perform a comparison every 10 microseconds, it will take us 100 million years. Well, maybe I can spin up a highly optimized million node compute cluster, and now I can run that entity resolution problem in 1 year. Unfortunately, it's still going to cost me $10 billion. What makes it so hard? Let's open up the challenge. Let's open up the problem of entity resolution to figure out what are the challenges that are hiding inside of it. First, entity resolution is algorithmically hard. We just described this n-squared problem, which is comparing every record with every other record. Even if we find an effective way to do that, we have another challenge, which is when it comes to clustering, we need to perform an n-squared log n algorithm, even worse, in order to arrange those records into clusters. And then as we perform clustering successively on different versions of the data, we have an n factorial challenge to determine survivorship across the generations of clusters. Second challenge is that entity resolution at scale is an imbalanced classification problem. This is because true matches are very rare events. So rare that a classifier that always says non-match will be 99.99% accurate. Building a classifier to get these rare events right is tricky, and we need a classifier that gets those rare events right because those are the ones that we actually care about. When it comes to building an accurate classifier, we have another challenge, which is that there is no ground truth. We don't have correct answers for any significant portion of that n-squared comparison space, and those answers are required to determine true accuracy. What's worse is building out any significant ground truth is cost prohibitive. It requires an enormous amount of subject matter expert time. A fourth challenge is that to build and deploy and maintain this entity resolution system over time requires multiple expertise. What we just described requires data engineering, data analysis, and machine learning expertise. It also requires subject matter domain expertise, data governance expertise, familiarity with regulatory and compliance issues. In order to deploy it effectively, you need to understand parallel systems, application programming, and cloud ops. And then to manage your data as a product, you need to understand customer requirements coming back from the data consumers and how to triage bugs and issues that they present and how to manage multiple releases over time. Finally, data change is destabilizing. A system that is up and running for years or decades must accommodate change, but there is no efficient way to modify clusters to reflect data change. Small changes in data can ripple across many clusters. Changes in data distribution can impact model effectiveness and overall data product quality, and there is no efficient way to monitor model performance to detect when retuning may be necessary. All of these add up to a truly challenging problem, but the good news is Tamr has addressed all of this for you. How do you know that Tamr has addressed all of these for you? Let's look at some metrics of success. Let's say you want to deduplicate or perform entity resolution in the entire population of the United States. We don't have the data on everyone in the United States, but we do have a data generator that we can use to generate synthetic data at the same scale. This data generator is febrile, and we can generate 330 million people records and add 50% duplication to get a total of 500 million records, 500 million records. records. And now we're going to perform entity resolution on those records. As a note, the default cluster size distribution from Febrile is a little bit conservative. In the real world, we find significantly larger clusters than what Febrile generates. So on our GitHub, you can find a version of the Febrile data generator that has been modified to generate larger clusters in its output. This actually makes the problem more challenging, not less. How do we measure success? Well, with those 500 million person records, we are able to run entity resolution under 3 hours and under $300 on commodity scale-out compute hardware. This is a 240-core compute cluster and a 60-node storage cluster, and we're running all the way from unprocessed records to build golden records. That's an enormous success. What's more, we can take a 1% change, a 5 million record delta that includes added records, deleted records, and modified records, and run that 5 million record change, that delta, against the 500 million records that are already processed in under 1 hour and under $100 on that same compute infrastructure. And we can do that with stable IDs and clear metrics of model accuracy. In short, you can have affordable hourly updates to the entire population of the United States with stable IDs and clear metrics on quality. This is the end of part 1, why entity resolution at scale is hard. We covered some of the challenges and some metrics of success, showing how with Tamr's approach, you are able to deduplicate the US population in under 3 hours, under $300, with fast deltas and stable IDs. Join me for the next part where we talk about making the easy part cheap.